Hi, I'm Yafah. I'm the head of data and trends at Epoch. I'm joined today by two forecasters from the AI Futures project, Eli Lifland and Daniel Cotatello. That's definitely not right.
It's fine. Thanks for having us, Yaffa. It's really exciting to talk to you. My understanding of what's going on here is that we wanted to talk to you about the concept of research taste because we heard rumors that you disagree with us about it.
I do.
And we respect your opinions in general and wanted to sort of hash it out. And in general, we have a lot to talk about. So we thought we would get into it. And then we thought maybe we should record it and put it up.
Yeah.
So we'll see what happens.
Yeah, I'm definitely excited to do that. I've had a lot of experiences with Epoch being put as like Epoch's timelines and thoughts on this being put in contrast with AI Futures. And I think there's like a lot more in common and there are some contrasts, but like it's to be interesting to like discuss this more explicitly.
Yeah. Also, just to note that we recently released our AI futures model for predicting timelines and takeoff. And so we've thought about this a good amount in the recent past, and also we have hopefully a framework that is useful for like discussing timelines and takeoff forecasts.
I think you guys definitely have by far the most impressive timelines model of anyone I know of, probably of anyone.
Thanks. Although, time for disclaimers, of course. That doesn't mean we know exactly when it's going to happen.
Yeah.
In fact, we're extremely uncertain.
Yes,
but,
despite thinking it's the most impressive, I still disagree with it substantially.
Yeah, I think it's the least bad model that currently exists, I would say.
This seems plausible.
Yeah.
In terms of the amount of detail and research we went into it.
So as we were setting up the equipment here, Yava said she had typical Epoch views.
Yeah.
And I was like, haha, that's fun. Let me try to guess what they are. So I will now try to guess.
Okay, yeah, go for
what
it.
your views are. Okay, so you think that there'll be some sort of transition to AI everything, like AI is doing all the intellectual work and all the physical work that'll happen probably in the 2030s. Not before then, but not after then. Like most of your probably mass would be in the 2030s. Is it correct?
I think that's true.
Yes. Okay. You think that AI alignment is not actually going to turn out to be easy, but that's okay because even if the AIs are misaligned, there'll be lots of them with different goals and values. They'll participate in the economic system. They'll follow the laws, etc.
I don't think I think that.
Oh.
I have the typical Epoch view of having wild uncertainty about AI risk and sort of not having sufficiently detailed views on it, maybe.
I see.
I think there's a decent amount of difference within Epoch on specifically this sort of question. In my personal views on this are that I think that it will get a lot more attention as AI becomes a more serious issue and that it will be like non-trivial but solvable to get AI that are relatively aligned, most likely.
Okay, cool.
But this is not necessarily the typical Epoch view.
Yeah. You think that it's at all possibly reasonable to use concepts like the efficient market hypothesis to talk about what the future of a superintelligence might look like? Basically, like you think like there'll be competing firms providing intelligence as a service to the blah, 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 rather than like more like AI 2027 style, like 1 to 3 mega corporations eating the economy with their armies of superintelligences type thing.
I think it sounds more like I think that the 1 to 3 firms eating the economy is not what it is going to look like. I think that in this sort of detailed view, there's like less confidence. It's like Doom, there's like less confidence at Epoch about what specifically this looks like.
Right.
I think a very consistent thing at Epoch is sort of throwing up our hands once we get to superintelligence.
Okay, next guess. And this one is kind of cheating because we kind of all know the answer already, but you don't believe in the software-only singularity or the taste-only singularity or anything like that. You do believe in the singularity, but you think it's going to involve this feedback loop with hardware design and hardware production, right?
Yep, that's approximately correct. I put some probability, 5% on a software-only singularity, but the bulk of the most likely, I think there's not going to be a software-only singularity and will instead be an economic singularity or economic takeoff, which I think looks much more similar to a software-only singularity than people often give it credit for, but happens in a different way that has different implications and and it takes a decent amount longer, though not too much.
Yeah, so at this point, I want to stop playing the guessing game and just ask you more about your views, actually. So can you tell us more about what you think the singularity looks like?
Yeah, so the thing I most likely think is going to happen here is the technology contributing to substantial amounts of economic growth, which is then reinvested back into AI. And eventually you get to a point where this sort of cycle results in the same sort of, going to infinity until you hit fundamental limits type growth that you see in a software singularity. I sort of expect this to happen in late 2030 to early 2040. it will involve, robotics and automation of broad amounts of the economy. Yeah, and it will not necessarily, and it will not, it will, potentially involve superintelligence, but will not be driven necessarily by like just the returns to like the increasing intelligence, although that's important too.
So
One way to imagine this is that you get robots, you eventually get to a point where you have robots that can produce other robots, and you get this sort of explosion in the amount of robots, and then those robots are used to make compute, which makes AI smarter, and you get better robots, and you get this growth that is super exponential.
right, but in particular, you think that this sort of perhaps you could give a timeline for us. So like, you've probably read AI 2027,
Yep.
right? Yep. So in that, it was a sort of relatively compressed timeline where over the course of 2027, they go from automating all the coding to automating all the AI research to really crazy super intelligences that are just like better than humans at every cognitive task. And then over the course of 2028, 2029, there's all the robot stuff happening like you described. So the things that you talked about like all happen in the story, but like in a relatively compressed period. Could you sort of like say those milestones in your best guess of how things are going to go? When do those various milestones happen? Like when is it like all the coding is automated, and then it's like all the AI research is automated, and then like there's AIs that are better than the best humans at every cognitive task.
Yeah, so
There's robots everywhere.
I definitely don't think of all of the AI research being automated as necessarily as big of like as important of a milestone as you guys do. I see this as happening as like all cognitive labor somewhere around 2035 is what I've said in the past. I might push that a bit forward soon, but right now I'm thinking somewhere around 2035. You see this all cognitive labor, and then you see, potentially some amount of superintelligence after that. But the date where there's, robots and everything has gone insane and you have 100% economic growth or something like this is closer to 2040. I know other people in Epoch believe it's closer to 2045.
Okay, so something like in your story, it'd be like around 2035. The last bits of cognitive labor that hadn't been automated already get automated, and it's now just AIs doing all the cognitive labor. And then in about 5 years after that, now all the physical labor has been automated too. Everything's done by robots, etc.
Yep.
Cool. All right.
Yeah. And this leads to a similarly bizarre world. At this point, not too long after your guys' models does, you guys have a super intelligence. What's the year range that you guys have right now?
It depends on whose parameters you use.
Yeah.
For me, it's around 2030.
And for you, it's like 2036, all right?
Yeah, that's roughly right.
Yeah.
In that range. I think Daniel's meeting is currently 2030.
And you guys have like wild impacts on the real world happening at about the same time, right?
That's what
Yes.
Yeah. Versus I have that delayed by a decent amount.
Yeah.
With like.
Or earlier, I would say. Or like, yeah.
Yeah.
Like, I think there could be wild impacts before superintelligence. Yeah, if the takeoff is fairly slow. Or like fairly slow by my lights, I guess. One thing I'm curious about is like, do you like you're emphasizing like this economic takeoff, but there's also this specific feedback loop, right, of like hardware R&D and hardware production. So you could imagine it feels like there's kind of three separate things. There's like specifically automating software R&D, then there's like, automating like hardware R&D and like specifically like building fabs and stuff like that, and then there's like generally automating the economy, causing growth, leading to like investing in everything, including AI.
Yeah, I think of these as I think of the economic takeoff and the impacts on society as happening roughly at the same time as like the automation of fabs.
Yeah, but if it was only specifically automating software and hardware R&D, then it would take a lot longer. Is that right? Or is the economic part is like load bearing, like general economic?
I think I would expect it to take a lot longer, just because of some of the earlier stages requiring a lot of investment from the rest of society that you wouldn't get if that were the case. I generally expect one thing that differs. I don't want to get too much into it because it's less of a standard Epoch thing, and if I don't have well-formed opinions on it as much as I generally expect more of a pluralistic involvement of a very large number of parties when this sort of thing is happening, and less focused on specifically on a few AI companies or a small number of actors.
Yeah. So, okay, that's really helpful for pinning down what your views are, broadly speaking.
Yeah.
Now I kind of want to drill down into some disagreements in particular.
Sounds great.
Is there a brief way to describe why your views timelines are somewhat different from ours?
I think the brief way is that I am skeptical of software-only takeoff, in particular research taste,
Okay.
imagining that experimental computers could have bottlenecked that,
Sorry, but are you imagining like in our takeoff model, we talk about like automated coder, which is like complete automation of coding at the AGI company or like all software engineering. And then there's like, there's various milestones up until superintelligence. And so Daniel and I have automated coder meetings roughly in like 2030 to 2032 range, like 2029, 2032. And you said that basically you thought we would get what we call TED AI, like top expert dominating AI, where like AIs can do all cognitive tasks, as well as the best human in 2035. So is it true that you basically agree on the automated coder range of thinking it'll be maybe around 2030, but it'll take a while to get to TED AI? Or is it?
Yeah. I think of some parts of, I think this approximately sounds right. I got maybe I would put it a little bit closer to TED AI, but yeah, I think I expect there to be some non-trivial impact from automating coding, but less so than I think your model has.
As Eli was pointing to, it seems like you think it's going to take a while to get from automated coding to full automation of AI R&D. And you were saying maybe this because of research taste being hard to automate?
I mean, sorry, this is like, no, it's not that. I'm skeptical of like, not quite the existence of research taste, but like the level of importance and impact of research taste. I expect it to like, I think choosing what experiments to do matters at all. And there's a degree of skill to it, but that this degree of skill caps out way earlier and has way less of an impact than the typical, than your guys' models give it.
So naively, I would think that if you thought that, then you should think that the gap between automating all the coding and automating all the research would be very small, because there's like not that much extra to be like.
I think coding's unusually easy, basically.
Compared to the other aspects of research?
Compared to like most skills. It seems to be being automated way faster than almost anything else.
Okay, so you think that like...
it'll be automated probably. Other tasks will be automated at around the same time as anything else. So like I don't know, but coding in particular seems to be running ahead of the curve and
Yeah. Also, maybe just to be clear, so the thing that we're calling research taste in our model is defined as the value that you get per experiment. So if researcher A has, research taste of 1, researcher B, or, automated researcher B has a research taste of 2, that means that like per amount of experiment compute they have access to, they basically get, 2 times the like that kind of like pace of software progress. Or like another way is like they have a 2x, like it's kind of this 2x uplift basically. Like, if you have this AI that brings you to 2 from 1, then you have this uplift of like a 2x productivity improvement. And like, yeah, and specifically in our model, we have a term for the variation in human research taste, which is like the like ratio between the top and the median human research tastes among research scientists at AGI companies. And Daniel and I both put that around like four-ish, like a 4x difference. I mean, this is like in large part based on the survey we did of like AI researchers where we kind of like asked them to give answers, and then we mostly just chose a number close to that. And I think the Yafah would put a much lower number there.
I think so. I also just generally think that like you get decreasing returns from the amount of ideas and from like the quality of your ideas relatively fast, such that, maybe there's one person who's just as good as 4 people, but once you have 10 of the medium people's worth of 10 of like the people who are median level worth of quality, it like doesn't matter necessarily as much. Not quite those numbers at all, but general concept.
So maybe this is the disagreement that initially inspired us to have this conversation.
Yeah.
It seems to me that research taste is an important thing, and that it varies significantly from human to human, and that the very best teams of AI researchers just have like 4x or 10x more of it in the relevant sense than like typical AI researchers. And my evidence for this would be, just look at the long history of like small teams of really smart, knowledgeable, dedicated people out competing like large bloated research institutes that have like way more money and way more people.
I think that per team, those small teams will very often have a lot more compute compared to the amount of compute had. I think this is explained by just like the amount of experimental compute different teams have.
But the total amount, let's take OpenAI versus Google, for example.
Yeah.
Like from 2015 to 2020, OpenAI had less compute than Google, right? Like much less. And it's true that maybe they were like concentrating it more in fewer people.
Yeah. I think of Google as best modeled as a combination of many independent teams, not one like comparison to OpenAI, especially at that point in time.
Do you think that if Google had like fired 2/3 of their researchers at random and reallocated their compute to the remaining 1/3, they would have beat OpenAI?
I think they probably would have had. I think it wouldn't necessarily have been at random. I also think that this is a weird point in time because Google was not necessarily optimizing for exactly the same thing here. I think of Google's strategy here as like trying to make sure that regardless of which idea wins, they have some amount of research done on this idea. There's like this diversity of like possible routes to impact sort of thing.
Well, I wish we had numbers
Yeah.
for this. I would guess that even if you control for amount of compute, like the best people are just substantially better than the median people.
My impression is that the people who have made like the biggest success, this is very confounded because once you do very well at research,
Right.
you're going to be handed a lot more compute.
Right.
And then you get handed more compute, the better you do. And so you end up with the best people consistently having the most compute. And this makes it very difficult to tell exactly to what degree different aspects are actually important. Various things that have updated me here, it definitely seems, one of the things that has updated me here a lot is the amount of spending on R&D compute being slightly larger, not substantially larger right now, than the amount of spending on top research, on like staff and salaries, indicating that like, you know, you have this research, experimental compute being seemingly more important, slightly more important for making progress at least.
But wouldn't you
And number
predict
of
that it
personnel.
should be much more important? Like,
Yeah, so this is an upper bound. My actual model here, this is my detailed model, which I add a bunch of qualifiers to, but I'm just going to say it, is something like algorithmic progress requires there's a large number of basically obvious ideas, or relatively simple ideas. Working out the nitty-gritty details is in fact technically difficult, and you have to do a lot of experiments and spend a lot of compute on researching this. Once you find which of 10 different things works, each of those 10 things potentially requiring a very, very large training run to really discover if it's actually a good idea. Once you discover which one works, you can implement it, and you have your new model, and then this leaks this sort of information, high level, which branch works, what some of the, not even what necessarily the details are, but the basics leaks very quickly. And that this sort of diffusion concern, and generally the like expertise that you learn from doing this, is what's driving salaries.
I mean, that sounds pretty similar to our model. I would just add to that and say some people are better at choosing which branches to explore than others. And some people are faster at looking at the incomplete evidence as it's coming in and correctly realizing like this is the good branch, let's abandon those ones. And some organizations are better at that too and faster at that too. And these add up to some organizations being able to just do better with less. Like they can like just make more progress with the same amount of compute.
Why do you think OpenAI has more recently like caught up? Sorry, Google has more recently caught up to OpenAI? Or like
Through
they
massive
appear to.
spending, right? Then don't they?
It's sort of hard to tell because they're not completely comparable to OpenAI. Their training runs, I don't think, seem to be much larger, but it's for Google, it is very hard to tell how much they are spending because they are in some ways comparable to a cloud provider, and in some ways comparable to like NVIDIA, and in some ways comparable to OpenAI. So it's sort of hard to distinguish these things. And for instance, NVIDIA spends a lot more on making chips than OpenAI spends on buying chips.
My guess would be it's a combination of catch-up growth and spending lots. And also improving the research taste. So like at the organizational level, their previous strategy of like let a bunch of researchers do a bunch of things maybe wasn't the best strategy. And now they have a more like prioritized, like these are the important things, we're going to do that. And that is an improvement in the research taste at an organizational level, you know?
Yeah.
There's some combination of those things would be my
Yeah, one thing that I think is right now a point in favor of your point of view, and which my model would at least say I expect to change, is the ability of Meta to do research seems to be, you know, much smaller than would be implied by their amount of compute. They're just models lag quite a lot behind. And this I think is definitely a point in your argument's favor.
Yeah.
I expect, for the reasons I've laid out, and that this is going to change. I'm wondering if this is like a crux that,
that's
this
actually,
update you in either.
That's brilliant. Yeah. If Meta pulls, so actually, do you off the top of your head, you know the numbers? Like, do you know how much compute Meta has compared to the other companies?
Not off the top of my head.
Okay. Well, if it's true that like Meta has more compute than the other ones, I would still not predict them to take the lead, given all the other stuff that I'm talking about. But if they do take the lead, and because they had like 20% more compute or something, then I'd be like, oh, that's evidence.
I think that
research taste doesn't matter, you know, or it's not. There's less variation in research taste than I would have thought, you know.
My guess is that they will have a competitive amount of compute, and they currently don't appear to have a competitive quality of model, with like one or two asterisks added after that.
I mean, I expect them to. They benefit from catch-up growth. So like, even with poor research taste, if you're just trying to like do the same thing that you've seen other people do, that's like
Yeah. I would expect.
But the thing that I'm sort of strongly anti-predicting is that they like take the lead, if that makes sense.
Yeah, I think the thing that I I think that I would expect that if they had a lot more compute, they would in fact take the lead. I would also, or significantly more, they would be more likely to take the lead. So I think we probably have a difference there, although I don't think it's necessarily likely that they're going to take the lead. I also think it's relatively plausible that they, take the lead on some things and not other things. They end up in the sort of category that Google, OpenAI, and Anthropic are right now, where these are like the three top companies. I think it's pretty plausible that Meta ends up in that category as well, just because they seem to be doing a very serious compute build out. There are some like details here with maybe they are in fact doing better than it appears from our perspective because they have a much broader audience globally. And potentially from their perspective, they're actually doing fine. It seems plausible to me that they have a fairly large amount of usage globally, even compared to like OpenAI or Anthropic.
Yeah.
They tend to do much better across like income brackets in the US.
Another piece of evidence that I think is relevant is zooming in. So we've talked about like the major AI companies, but I feel like we see similar patterns across all sorts of other domains of research. So for example, within AI research, if you look at, academic labs or like individual researchers with their tiny amounts of GPUs, there seems to be huge variation in how much in their productivity, basically.
Well, I think of this as pointing in the opposite direction because you have all these you have way more academic researchers than you have people at labs, especially in the past. This is becoming less true over time. But very quickly, labs started surpassing those other researchers because they had more compute, according to me. You just have academia has far more people.
To be clear, my position is not that compute doesn't matter. Like if you want to sort of if you want the simple version of my position, it's basically like compute multiplied by research taste.
Yeah.
And so obviously, like the fact that they had all this compute, well, that's like a literally multiplicative factor on how much they can get done. It's a huge deal. I totally buy that that's why, or like a big part of why they went so fast. But I'm saying it's not just compute. It's compute multiplied by research taste, and they both matter, and they both matter like similarly. And in fact, I would say that the fact that they're paying similar amounts for both of these things is like maybe evidence in favor of our view, I should say. Another thing but back to the point that I was making, it's just like if you take all the academics and you like sort them into buckets based on how much compute they have, and then you look at a particular bucket, and then you like rank how productive they are. Like the most productive academics are going to be like orders of magnitude more productive than like the median, would be my guess.
I would expect that to be the case, yes.
There we go. And so that's an evidence that like, well, we controlled for compute by making that bucket. So they all have the same amount of compute in this bucket. And yet the best ones are like producing 10 times more than the median ones. And so that would be a factor of 10 in our like a parameter of 10 in our model.
Do I expect this to hold up if you actually get substantially? I expect this to plateau at a rate not too far away from that. I also think that I also do think that like there's maybe not median, but maybe like the 25th percentile people who are like nowhere near the top, if you give them a lot more compute, are going to do a lot better. I would expect. This is not an experiment that I think we have like good evidence on either way. One thing I think is the case is that like it's not obvious to me that we should expect the sort of research taste direction to be very hard and to like be the sort of thing that comes later that like we shouldn't have seen already. I would have expected to already see this sort of thing if it were as important as like you think. I don't know.
You mean
at least
to already see training AIs for research taste?
What? Yes.
Yeah.
I think that so far we haven't seen like progress or attempts on this. And like this to me is indicative of people not really thinking it's going to be that helpful when you do it. I think right now like there's really not that much focus on trying to generate ideas with AI.
Yeah.
Like major labs.
Well, this gets back to the efficient market hypothesis thing, perhaps.
Yeah.
I think
I generally expect like top labs to be trying like the things that seem like good ideas to them.
I mean, I also expect them to try the things that seem good like ideas to them. I'm just not making a very strong update on the fact that they haven't made lots of progress on this or tried very hard on this, that it's not.
Doesn't your research taste numbers come from what people at labs claim?
Two different things. There's a research taste for humans, and then there's the research taste of AIs currently. The research taste of AIs currently, we are assuming, is quite low because it seems like there's not much evidence that AIs can autonomously manage research projects or contribute significantly to like.
This definitely seems the case for AI research.
That's right. So like our initial settings for AI research taste, automated research taste is like quite low. And then we have like our guesses as to how it's going to improve over time. And that's the main thing that determines when you get to the full automation of AI R&D, because we think the coding is going to happen first and then like the research taste will sort of catch up.
What's my take here? I feel like I would have expected to see if research taste was actually like so ineffective here. Was already low here. What was I going to say? I think I would expect models being particularly bad at research taste to result in them being worse at math than they are. It feels like math is the equivalent of like a AI research without the existence of compute. And we see models being very unusually good at this.
So I think I just wanted to like clarify or like flag that I feel like we're sort of switching
Yeah.
arguments here. Like there's the question of like how good are the models at research taste and how good are they going to be?
Yeah.
And then there's the question of like how important is research taste to have?
Yeah. I think this is true. Okay. There's a lot of like, you can get into a fairly mechanistic and detailed framework about how AI research works. I think this is interesting, but ultimately very difficult and requires making a lot of fairly opinionated choices in a way that I don't end up trusting myself or others to do. So when I think of how to do this, I have a very simple amount, basically amount of compute and amount of funding going into AI companies, going into AI labs leads to an increase in capabilities over time. We assume that this relationship stays roughly the same as it's been in the past, which you can just see based off what trends have currently existed. And so as you get this compute goes to capabilities, R&D compute goes into capabilities, capabilities then lead to more revenue, revenue then leads to more investment, and investment leads back into R&D compute. And this simple cycle, and the cycle has at a certain point, as you get towards full automation, you get this full automation, you get explosive growth, so revenue starts increasing much faster, and you end up with this cycle taking off. And I think this is, a much more simplified model that doesn't require me to make nearly as many opinionated decisions. And in particular, something I like about this is that for any stage I think we have a lot more data on being able to say, how does this lead to this? What does this look like in the real world? How would I know if I were wrong or if this had changed? Which is something that I think is somewhat missing from some of the AI Futures work.
Yeah, this is a nice place maybe to talk about the importance of simplicity in modeling. So like, there's a spectrum of models, and like you could go even simpler than yours, and you could just be like, here's some graph, here's a line, I'm just going to extrapolate that line.
Yeah, sure.
And like that would be like even simpler than the model you just proposed.
Yep.
And so there's like a trade-off to be made between simplicity and other things. And just as how you prefer your model to like the super simple model because you quite reasonably think that like you can like you understand the structure of what's going on a little bit better than what that simple line would predict that allow you to make these like somewhat more interesting predictions. Similarly, like I feel like we understand the structure of what's going on a little bit better than your simple model and are able to like, make some adjustments to it and complications to it that we think are going to make it more accurate. That said, the more complicated the model is, the less other people should trust it, right? Like it's one thing for me to say like every piece of this model, I like know why it's there and I know why it's an improvement over not having it there. Because like, I thought about the simpler version and then I added the complexity to deal with what I thought was like something that needed to be dealt with. It's another thing for someone who hasn't seen your model to like look at it and be like, oh my God, like, and I agree that like, it's harder for someone to like come to trust our model the more complicated it is basically. And the more simple it is, the easier it is to understand it. And so like, in some sense, we're sort of like shooting ourselves in the foot or in the face by making a complicated model because it's going to make it harder for people to like come to believe us or trust us, but that's fine. We're not trying to like proselytize here. We're just like trying to think through what we think the future is going to be looking like. And so for each particular part of our model, well, it was there for a reason. And we thought that if we had taken it out, then overall it would be less accurate, And it's true that this does mean we end up making a lot of like, questionable guesses, but in the same way that like, yeah, like for each particular thing, it's like, well, we feel like if we took this out, then it would be less accurate for these reasons,
Sorry, I was to say I don't really think simplicity is like the main thing here in terms of comparing the two models. Like if I understand correctly, Yafah's thing is like the only, like basically you make your AIs more capable, then they make you revenue, which increases your valuation and investment, and then you use that like extra investment to like do more things. But like in some sense, an actual simpler thing that like would admit, like for example, like one way it could be simpler, a way to like possibly model software only singularities. Like this basically doesn't model what we think will happen if there will be a software only singularity, right? Because like,
this does not have a software.
Exactly. And I guess I'm just saying like you could have a simpler version, right? Which doesn't go to like investment or revenue. It's just like you increase your capabilities, you increase your capabilities, and then that allows you to like become more efficient. Like I don't know, like I guess I'm just like it doesn't.
There are others.
Yeah.
The advantages here that I think you get from this are a ability to like empirically measure. Hopefully each stage of this, there's some that are more sus than others. But I feel like this is a thing that I particularly like being able to do is go for each of these steps of this thing, I have a clear graph of what the real world inputs and outputs have been so far. And if my model goes wrong on any of these stages, I'd be able to notice that it stops, that the like trend line that I had here stopped working, and I'd be able to update. And this seems to me much more difficult with the AI Futures model, where some parts of it are based off interviewing 5 people, or about like more broad things that don't necessarily show up until you get to some farther out milestones. This does happen eventually in the Epoch model, in this sort of model I'm thinking about, but to a much lesser degree. And like, for the most part, I can go, here is a chart of data that I have gathered with an X and a Y axis on which this is the trend, and I will notice if the trend fails in the future.
You have compute. We know the mapping of compute to ECI.
Yep.
Or like R&D compute to ECI. We know the mapping of ECI to revenue.
Yep.
Then we know the mapping of revenue to investment, and then that's a loop.
Yeah.
And then, okay, so
You would want more, ideally you want more evidence even of that.
Yeah.
But this is like the general concept is yes.
yeah, but
That you have,
so
there's a few, yeah.
So there's an assumption that like ECI versus revenue will just like continue
Yeah.
in a certain way.
This is one of the weaker parts of the model, I think, and I'd like to,
yeah.
this is one of the things which I'm like, when I have this, I'm like, this is the thing to research, and one of the things I want to pay most attention to is figuring out more data that will support or confirm or lead to more evidence. And let me think about this in particular. I've like papered over adoption and diffusion and these sorts of things, and to what extent do the highest capabilities drive revenue? This is the sort of thing which I think we can research using like real world data, using polling, monitoring of what usage is like, and various things like this.
One thing I want to add or clarify though is that our model also makes all sorts of predictions. Like there's like a whole bunch of different variables that are being tracked, including compute, including revenue, including ECI, and also uplift.
Yeah.
You know, and so like we also can like notice when things. In fact, there's more ways for us to notice when things are going off what we predicted because there's more variables that we're making predictions about that we can be tracking. You know, now the difference though, and this is what I think you're trying to say, is that your model only has variables that you can track, basically, whereas in our model there's like 5 variables you can track and then like 5 more variables you can't track. You know?
Yeah, I think that's a lot more of it to some extent. Yeah, there's other reasons I prefer this model, but this is when I am doing this sort of forecasting, I know that it's like having unknowns which I can't track, to me at least, makes me trust the model a lot less.
Terrible, but we think it's the least bad option. But is that basically the crux? Like, you think that like whether or not, like previously you said that you don't think there's going to be a software only singularity. You think that it's going to be this more like economic gradual thing.
Yeah.
Is like the fundamental driver of your belief there basically this thing that we were just talking about how you have this sort of like philosophy of science position that like this is the right way to do modeling and this is the more like epistemically reliable thing? Or is it that for like other separate reasons you don't believe in that? And then like I'm curious.
I think as like I'm not sure how like much I've thought of the underlying philosophy of this. I think I have a suspicion of the sort of things which you can't track and get empirical data on and lead to like weirder conclusions or conclusions which don't match my understanding of the world. I think there's like other reasons why research stage doesn't quite match my understanding of the world or how I think about things. Mm-hmm. I think it's like very hard to resolve some of those. Mm-hmm. And this version of things conveniently doesn't have that. It also has the fact that, if research stage is a big deal, this thing,
hopefully,
this sort of model would, predict incorrectly.
Yeah, although by the time
you would expect.
By the time it's predicting incorrectly, it might be kind of late.
Yes, but this is the sort of inconvenient thing about a lot of the cruxes here, is that a lot of them is that our models look very, very similar up until takeoff to a decent extent.
Yeah, I agree.
Especially the updated version of your model. Mm-hmm. The newest version has like long enough timelines that they start looking like mine. I think that there are a few things that we can still expect that would be different. One thing which I think might update both of us either way is the amount of AI usage internal to labs.
Like if they start heavily doing internal AI?
Yeah, if they start all using coding assistants to do a lot of things, and they're spending like a substantial fraction of their budget on the equivalent of Claude Code for their employees.
How much do you think they're currently spending, and how much would be enough to...
How much do I think they're currently spending? I think they're currently spending definitely less than 100 million a year. Probably less than 10 million a year. Though probably there's enough outliers that it gets up a bit higher than that. I would update if they spent 5% of their budget would be like a pretty solid update for me. Also a trend line in this would be a pretty solid update to me where it's taking up a much larger percent of their spending over time.
So the thing is that in our model, we think that you're bottlenecked by experiment compute. Like, again, the simplified version of our model is research progress is equal to like experiment compute multiplied by your research taste, which is basically like how well you manage your experiment compute. And so I think our model predicts that you don't want to use like, well, we also think that there's diminishing returns to like spinning up lots of parallel copies of agents thinking about research taste or whatever. The point is that like when we tried to make guesses for what fraction of the budget would go towards experiments versus like AI agents managing the experiments and doing the code, I think we came up with something like 5% for the latter. So
I think if it got to 5%, I would in fact. This would
Okay.
that even that would be an update for me. That's
cool. Then yeah, maybe this is.
I mean, it wouldn't be.
Yeah.
Yeah, it wouldn't be as big of an update for me as bigger than that. But 5% would be an update for me. That's
I'm
like,
saying that if it was bigger than that, it would be like more than we predict.
yeah.
You know, yeah.
Yeah.
There's just a lot of uncertainty around like.
I mean, if it were bigger than that, I think it would be more consistent with your views than mine. So it'd still
Sure,
be an
yeah.
update in favor of your views.
Yeah.
And if it were much smaller than that,
Yeah.
then I think it's more consistent.
It's just hard to predict what's going to happen, I think, because there's like, like it might be the case that you mostly care, like let's say you're the case where you've like fully automated coding and you've also done it very cheaply. So basically like, you can implement like any experiment like quite cheaply. So you don't have that much reason to spend much on coding agents. And you're and then you're automating research taste. And it's unclear exactly what the returns will be, but it seems like looking at like humans, like often like people like relative to the importance to their organization, like people don't spend that much time specifically on research taste. This would also be evidence in favor of your view, obviously, but our view is something like it's really important, but it matters like the quality of the thinking more than like the quantity.
Yeah.
And so if you think this is the case, it's just like not obvious that there should be necessarily be a smoking gun of like, oh, they're spending like a lot of their compute on like these things when like actually like because like it's so efficient to spend it and because there's some diminishing returns as well, they want to spend still a lot of their compute on like experiment compute and training compute as opposed to like running agents.
Something else that would update me here is if a smaller lab founded by some like prominent researchers like SSI.
I agree. That would be big bullishness. Yeah, huge
Yeah.
bullish update for research taste and the importance of it.
If SSI did like really well. Yeah.
Again, the ironic thing though is that like I'm not predicting SSI is going to do.
Yeah.
Like I think it's multiple.
There are a lot of like, there are a lot of like things which would be a big update towards your view, but you still don't think are like more than 50% to happen. But like, much more likely in your world than my world, I think.
Sure. Yeah.
Conditional on them not getting a bunch more compute.
Yeah, that's right.
What's another situation? So we have Meta, but the problem is I'm not quite predicting that's gonna happen. Or like I think that there's a bunch of alternative things that could happen with Meta's capabilities.
I wanted to ask you a question actually.
Yeah.
So you on your model, isn't it the case that the relationship between ECI and compute has not been stable over the last 5 years? Like if I recall correctly, ECI grew especially fast over the last 2 years, but the rate of growth in compute was, if anything, slower over the last 2 years than in terms of like scaling up the training, etc. So
one thing that would update me here. So my current model of how algorithmic progress works is that it is occasionally there are large amounts of progress that is sort of bundled up in time due to some major discovery, with the most recent one being reasoning.
right.
Sort of things that can update me here are if there's a second is there's an additional acceleration in ECI or in capabilities in general relative to the amount of compute, that would be an update towards me.
Right.
If we look backwards in time and we find out that it was even slower, that could potentially be an update towards me as well, for me as well. I do think we see a bump not too long before we potentially see a like slight jump in a non-trivial jump in a way that like might be consistent with the in the amount of AI compute, in a way that could be consistent with it leading to this, but I think that's probably not the case. Maybe we can get more evidence on that either way. Yeah,
Cool.
I think so. Would it be an update towards your view if AI progress slowed down, if the ECI slope slowed down towards more similar to what it was pre-reasoning? Because I think that that's plausible, although I'm not confident.
I think it'd be an update towards your view, right?
Yes.
Yeah.
So yes.
Yeah.
Would that be an update for you?
That's right.
Would that be an update for you towards my view? Yeah.
Yeah, I mean, in general, we talk about this in our blog post a little bit, but like one of the like very simple models that I put some weight on intuitively is the like just extrapolate revenue
Yeah.
model, which is spiritually similar to yours, perhaps.
Yeah.
And,
Yeah.
yeah, and if progress continues to accelerate instead of going back to more of the long-term trend in the next year or two, then that would be evidence against that simple model and more towards like, holy shit, there's feedback loops happening. It's,
Yeah. Definitely
Exactly.
to the extent that there is also break in the revenue trend. a positive break in the revenue trend would
Right.
be an update, I think,
Yeah.
towards review. Although this is not necessarily consistent with the rest of Epoch, expect, there's varying views. Expect a slight slowdown.
So do we.
Yeah. I'm not sure if we have the same. I expect fab lead times to be relatively significant, and this to like slow down the reinvestment of revenue. Revenue drives investment, which then drive compute, but the time between investment and new compute is going to increase, according to me.
Yeah.
This is less consistently agreed upon Epoch, across Epoch, though. Yeah, I think there's a problem here where a lot of our views predict fairly similar things in the next few years. Well, not our views do. You have before 2030, there's some wild things, right?
I mean, I just
And
have
you're-
more
yeah.
probability mass
Yeah.
on sooner
Yeah,
scenarios.
yeah. I think it's like plausible that the next 5 years play out or the next 4 years play out in a way that does not give much evidence. Well, no, I actually don't expect that to be the case. I feel like
I feel like we should talk more about takeoff disagreements and timelines. Like,
Yeah.
obviously they're correlated. Like, if the ECI thing happens, like I think the main reason this would like affect my takeoff is because it would find timelines longer, and like which I think is like correlated with longer takeoff because generally like more stuff leads to like capability growth being slower, like more inputs. But yeah, I mean there's a few things here. Like one is like getting more evidence on this like human variation in research tastes. Like if we could do that, that would be really good.
yeah.
There's another thing we can talk about back on the subject of research taste. So you said something about how like, well, maybe some person is better 4 times better than the median, but like you can't get like 4 times better than them or something. And we also think that like there must be some theoretical limit to research taste. Like it must at some point you really are just like you've hit the limits of research taste. You just have to do all the experiments, and there just isn't any like extra juice that you can get out of like more cleverly choosing which experiments to do in what order, right? We agree with that at some point. However, our position is that like theoretical limit of research taste is like far away or like not very it's like humans aren't bumping up against it would be our position, and so there's like room to grow past
One thing that would update me here is, or that updated me against research taste in general and towards a general view that like it's about shots in the dark, or just like the number of implied failed large-scale training runs that OpenAI seems to have.
Wait, that updates you against research taste?
Yes, because this made me, or at least it updated me against their like research taste being very useful at this point. To me, maybe this just doesn't update us either in either direction.
Isn't it like a relative thing? Like
Yeah,
Like doesn't that mean that if they had better research taste, they wouldn't have made all this failing train runs and they would have gone faster? Like
in general, the thing that would have made me more confident about research taste is seeing, I guess, a smaller number. No, it does. It updates me against the degree to which current human research taste is very, very good, or is very different from what you might expect from like a median person necessarily. There's a question about like how many failed experiments would you expect to have if you had less competent researchers?
Yeah.
And I guess one thing I could have said if I saw like all of their large scale training runs worked, I'm like, oh, okay, that's, and this isn't true for like less competent labs. Then I'm like, okay, I've learned something about like the difference between OpenAI. One thing that might be plausible here, that we might be able to get some data on, is just the number of failed experiments between different labs. We might be able to learn this.
Yeah. I mean, it's all about a relative thing. Also, one thing that brought up in my mind is like, I feel like, I've heard people say several times, well, like, this company has the best team for this aspect of the training process. This has the best team for that aspect of the training process, etc. And I feel like maybe that's some evidence, like people are like acknowledging that like within companies, there's like specializations, and like some teams are like more competent at like developing algorithms or executing training runs for some parts of the process. Maybe that's like relevant.
Yeah, one thing that might update me here is that I don't expect things like that to be consistent over time.
Okay.
In a way that makes me like a little bit suspicious of this being like an inherent trait that I should expect to scale very nicely.
Okay. Well, yeah. I mean, I'm not confident in that. But I have heard a few.
No, I definitely think this is like true at any given point in time. There are teams that are better at something.
Okay.
But I'm like, a few years later, should I still expect that team to be
I
better?
see. You're just like they happen to like come up upon an insight at that day, so they were like ahead of the other teams for a year. Yeah, maybe.
Yeah, this is the sort of thing I imagine happening.
Okay.
if we tried to sort of like fit your view into sort of our framework and our definitions, it seems like your view is that like the limits of research taste are like not that far above the current best human, such that like the companies are sort of like, as they get more competent and pay more for researchers, they're sort of like starting to ask them towards the limits of research.
I think that,
and therefore are just like, it's all about compute as they like approach.
I approximately think this is the case. Yeah. I think that something which I plausibly have is different from you is that I think it's the case that running experiments is in fact extremely technically hard, and that you need to have a certain number of researchers to effectively use your research compute.
I don't think I disagree with that.
Yeah, sorry, but they're like this is driving the amount that they're paying people. In addition to maybe don't disagree. In addition to diffusion, algorithmic diffusion.
Yeah.
One other thing I want to say about research chase limits real quick is like, I think our model like it's unclear that the framework of our model is the best way to think about it. Like it seems plausible to me that in the limits, you just are doing the very different paradigm from like anything like running like medium to large scale experiments. Like, you know, you might like if we live at the limits of intelligence, it can just kind of like introduce a lot of things for or something. But yeah, so it's not that our model's like useless for that, or like it's not. But I would just flag that as unclear. Like I would say that I think there's some probability that you get to that point. You don't even like really need experiments much.
I also have some probability on that. One thing that I find plausible in terms of just like a software intelligence explosion that doesn't require research taste at all is just that you get a big enough. It seems plausible to me that just being able to like run a very large number of like sort of obvious ideas, that like right now the complexity of running ideas, of like running an experiment is high enough that you run reasonably big experiments because implementing them takes a while and it's pretty high effort. But maybe if you had automated coders that could do the whole implementation, which I think is a little bit more complicated than just an automated coder, but who are able to take care of all the nitty-gritty details, maybe this is actually, without any research taste or automation of the full researcher stack, maybe this alone gives you a very, very large algorithmic progress boost. This seems plausible to me. And you don't even need to you can get similar results just from a boost that is not necessarily a runaway effect, which you might have here. I also think it's plausible that at a certain point you get AI, that can circumvent, that is smart, and I think probably you get AI that is, significantly better research taste eventually. I particularly enjoyed the idea you guys had in AI 2027 of AIs that are of super intelligent AIs doing good old fashioned AI style. Yeah, just making a bunch of symbolic logic rules.
But success
you just need to scale up to a trillion common sense symbolic. I love that idea. It made me very happy.
Okay, I feel like we should try to maybe summarize or like I kind of want to go back again to like cruxes that we would update on evidence. So like one possible thing is if we could somehow get more evidence on like variation within the human range of research taste. I think we could also get similarly good evidence. Like we could get some evidence on like how high the range is, like sort of how high you can go above humans by looking at kind of like the difference between like the 99th and the 99.9th percentile human, stuff like that. And then it seems like there's also like, and then the main other thing, I guess, in our models, like how quickly research taste is improving. And it seems like we both agree, I agree with you that, like seeing companies work on more on research taste is like towards it being more important. If that happened, I think that, so one nice thing about tracking about, the AIs obviously is like, we can do a lot more experiments on them more quickly and more flexibly and stuff like that. So like, once we have AIs that are like getting into the human range of research tastes, we can potentially do like a bunch of experiments to basically figure out, for example, like, okay, this ECI level, they have this amount of like research taste, and then we can have like the ECI research taste mapping, and then from there we should be able to get a sense of like, basically like what, like how quickly things are improving, whether it seems to be like plateauing, and that's something that doesn't, like in our model for like ease of like sort of like us doing the parameter estimates and modeling, we kind of broke these things of like, how big is the human range research case and how quickly the AIs move through the human range. But like once we can actually be experimenting with AIs, we don't need to break those up. We can just directly experiment and see like, the ECI to like base curve.
One thing that's interesting that seems plausible to me here is that, or could be an update, is not even seeing research, just seeing the equivalent of research taste being done by AI in some non-AI field, which maybe has, a smaller number of people. So like the capabilities you need to be on the frontier are much lower. And so like you can have an AI that's not at the point where it could do research taste competitive with AI researchers, but maybe it could do research taste competitive with, I don't know, some more obscure field, which I won't name because I feel like I'd insult the field. Theoretical underwater basket weaving. Like, I think that this would be, seeing this become like a very common and impactful use of AI, and seem to speed up the field a lot, and seeing it cause the field to be a lot faster in a way that was convincingly primarily or driven by the research taste in some way, would be interesting to me.
You guys are compiling some I forget if you already released them, but you're compiling some sort of like open math problems, right?
Yep, we released it.
Yeah, cool. So if the AI has solved that, or like if the AI has solved some of that, is that an update for you at all?
It's definitely an update as to what would it be an update on?
Wouldn't it depend on how they do it? Like if they solve it by doing like huge amounts of parallel computation, then it wouldn't be. But if it was like single rollout, solve these things.
And we're trying to figure out what direction this would be an update in. Because on the one hand, if this happens, and then it's a year late, if we have like some example of it doing great on research taste in some field like math, and then a couple years later we still haven't seen them implemented on AI, now that feels like it should be an update against research taste being very important for AI takeoff. But maybe this requires the efficient market hypothesis too much for you to take it seriously. To me, it's definitely an update on, oh, they're getting good at research taste. It does. I think if they...
Yeah, I agree with that.
Yeah.
Although, of course, it's probably different for different domains. So just because they're really good at one domain doesn't mean they're really good at others. But it's probably all correlated.
Yeah.
Yeah.
I think that if we see them getting really good at research taste and this seemingly having a big impact on math, then this is an update towards the effectiveness of research taste. And I then expect, but it's not an update if 2 years later there hasn't been a huge impact on AI. Or it's an update on like the effectiveness of research taste absent constraints from experimental compute or similar. But if there hasn't been some big impact due to this after a bit, then this is an update on, oh, experimental compute constraints mean that this increase in research taste isn't as impactful when you have them.
So like, I want to give another analogy. And I think this is like dear to my heart in some sense, or like, I think it's part of the causal history of how I came to have the views that I have, which is why I'm mentioning it. And I also think it's a good argument in its own right. So I feel like there are just many cases that I'm aware of people being like, X is impossible, can't do it that fast because bottlenecks, real world constraints, blah, 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 blah. And then someone just goes and does it. And Elon is a example of someone who often does this. I feel like, remember you were talking, was it you talking? Some of us had some conversations with some data center people.
I wasn't there, but yeah.
Yeah. And then I had a very similar set of conversation with a different set of data center people when I was at OpenAI, being like, oh, like you can't get a data center built in a year. It takes multiple years to build a data center. Like first there's this part of the process, then there's this part of the process. And we're like, can't you speed it up? What if you're trying really hard? What if you're spending lots of money? Like you can speed it up a little bit, but it's just like inherently bottlenecked on blah, 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 blah. And then it's like, nope, Elon just went and did it. Like they were just totally wrong. Like they thought that it was bottlenecked by all these things, but like they were just a skill issue. So like, yeah. I feel like there's just, and I feel like this is also...
I don't think we actually disagree on this. We might just disagree on the reasoning for why this is the case. I can explain why I think this is the case. I've noticed this is like, to me, a classical thing that happens when you are trying to research Moore's law. Is you'll talk to people who work on semiconductors. Yeah. And they'll be like, no, these things are going to run up against limits. You're really not going to be able to continue it. No matter what year you ask people, they will tell you yes. And they will be wrong. I think this is because it is difficult for people to imagine things that are sort of very, even more so for data centers. It's difficult for people to imagine things that are very outside of the status quo with how their research typically works, and that are sort of either far off or overcoming these sort of challenges that have bugged them for years. But, it's just difficult for people to imagine those challenges being solved, even if there seem to be, and people are over... what's the other example I want to use here? I want to use power as the example. If you ask people if you can scale up, if you can build tons of power, 10 gigawatts of power at one place in 2 years, they'll say no. I think this is because in America, we have had a fairly steady, approximately, the amount of power in America has plateaued for a couple decades because according to me, demand has plateaued. And this leads to a domain where people are focused on making power, not necessarily scaling up the amount of power, but replacing existing things, keeping prices low. Right. They have long enough timelines, and it's fairly predictable when you'll need new power. It's when other things are going out of commission. And as a result, you have this domain where the ways people think of, the tools they think of as available are the very low-cost ones, which are typically take a while. And people won't imagine the very high-cost ones that aren't actually like reasonable things to do inside of the paradigm they operate in. In the case of power, they won't imagine taking jet engines and using them to power your data center. This is now done. Or similar things which are like, cost 2 or 3 times more than normal, potentially. I'm not sure if jet engines in particular do, but they could. You could imagine things that cost 2 or 3 times more, but power is not nearly as expensive for data centers as GPUs, and if power costs 2 or 3 times more, it doesn't really impact your bottom line that much, and people really do want it a few years earlier. Yeah. And so you get this sort of difference. I don't think of this as necessarily due to like the capabilities of the people involved. I think of this as due to the specific constraints and money involved. I actually think of this as like primarily urgency plus money plus like people over focusing on the problems in their particular field and thinking and being over pessimistic about those problems getting solved or significant breakthroughs, but not really due to like Elon Musk being particularly good. So I think a lot of other people have done this or are capable of doing similar things. There's a couple of differences. XAI Colossus 1 is the fastest I know of. XAI Colossus 2 got delayed and appears to be running behind schedule by a non-trivial amount, and I don't think will be quite as fast. I also think that at least some of his lead on XAI Colossus 1, it's like slightly less impressive if you factor in the time between him buying the building and construction starting on the building. And there was this very unusual thing with Colossus 1 with him buying a building. And this is not how it's typically done. And if you count starting from when he bought the building, it's like a little, I mean, he still does it unusually fast.
Yeah.
But they notably don't have a compute advantage right now. For instance, the current largest data center is being done in terms of power usage, and soon in terms of compute is Amazon's data center, is an Anthropic Amazon data center. And that's just the same building stamped out like 20 times or something that Amazon's been stamping out forever, and they just made a bunch of them and filled them with Trainium 2, and they currently have the largest and will sort of are neck and neck with XAI for a gigawatt.
So then applying that similar sort of reasoning to the case of...
You mentioned data centers?
then I'd be like, okay, so right now, the way that AI research works is you explore a bunch of different options, do a bunch of large experiments, you see which one works, and then you like focus on the branch that seems to be working, as you described. And if you talk to some of these people, they'll be like, yeah, it's just inherently hard. You don't know which branch is going to work until you do the large experiment. And I'm like, maybe you don't, but like after we have, 1 million super intelligent agents thinking at 50x speed, maybe that's not acceptable to have half your training runs fail. Like maybe those million super intelligences thinking at 50x speed will be able to like do a bunch of cognitive labor to like correctly predict, better, maybe not perfectly, but like better which of these training runs are going to be duds and which of them are going to work. And then that can give you a significant speed up, That's kind of where I'm coming from.
Yeah,
like, I think there's a sort of team's mindset.
I think you can get this to at some point. Right now, I just think of like, I would expect to see this. One thing I would expect to see this sort of effect earlier in other industries than AI. AI seems to be pretty far on the end of like, you're working with a black box and you need to do large scale experiments comparatively. And I would expect to see, oftentimes you actually see the opposite I sort of have the opposite view of how Elon Musk's things work. And how like you should imagine this. Versus you're thinking of this as, oh, Elon Musk is like very smart and good at using the resources he have to go faster than other people. Versus I'm thinking of this as Elon Musk is willing to throw away more resources on getting something faster than everyone else. And that's mostly what's at stake here. Not him being very clever about it, just him willing to go with the options which cost a bunch extra.
I agree that applies in the Colossus sense, but it doesn't explain SpaceX.
I think it does explain SpaceX. SpaceX does a lot of failed rocket launches, and I think it does more failed. My impression is they did a lot more
budget than Blue Origin or any of its other competitors. Like the legacy space spends more per year. Blue Origin spent more per year.
My understanding is that the difference between him and Legacy, I don't know much about. This is not my field, but my understanding is that compared to Legacy, it does a lot more failed launches, and thus is able to.
That's certainly true.
I also think in particular in this case, it's like sometimes the case that in aggregate, doing more failed launches is actually like, more efficient to learn and definitely like faster. And I think of this as like the driving force behind this thing. It's just the ability to the willingness to, we'll solve it by scaling up our battery like production to large enough that it becomes cost efficient. This sort of thing.
I totally agree with that. But again, that's him using his resources better because he had less money than his competitors. And yet he was able to outrace them by just like throwing the money. Like he knew how to spend the money better, basically,
Yeah, I don't have a good understanding.
They wasted their money compared to him.
Yeah, what's my take here? I don't want to get into the nitty-gritty about space stuff because I don't actually understand. I don't have much knowledge here. I know with data center stuff, it's like, it is the case that he has less money than OpenAI.
Yeah.
And he has less compute than OpenAI, I believe. But to the extent that he is throwing his compute at, getting models faster in a way that, doesn't necessarily even throw away. I mean, first of all, in that particular case, it's not keeping him on the frontier. It's getting him somewhere nearby. It's like, and also, because GPUs are so expensive, it's not actually the major cost.
I think there's even a parallel to that with the AI stuff where, some of the big advances that OpenAI had over DeepMind were scaling, right? Scaling of language models. And that was an example of throwing lots of resources at one particular thing. But it was precisely that choice to throw lots of resources at that particular thing that they made and their competitors didn't make, and that was why
I think
pulled ahead.
Very soon after GPT-4, at least Gemini 2 or 1 one of the early Gemini 1 Ultra or something was actually a bigger training run.
I was thinking about GPT-3 and GPT-2.
Okay,
Or like
GPT-3,
back
I think yes.
before scaling was a thing, and like
I mean, the Prompt 2 was relatively large and before GPT-4, I think.
sure.
I agree that like they had some early successes there due to like spending more. I think in like, you know, Google's decisions there don't really seem to have mattered in the long run. They seem to have caught up.
But OpenAI, like from Google's perspective, they could have crushed OpenAI in the cradle if they had just like gone all in on language models in 2020 and like scaled them
It's
up.
not clear to me that that's true, given the amount of like people leaving Google that occurred, regardless. But
I mean, not clear.
yeah,
I mean,
yeah.
I mean, they could have like.
I agree that they could have like, yeah. I don't think of this. I mostly think of this as like a selection effect. The people at OpenAI getting a little bit lucky.
Like if they had released ChatGPT like a month before OpenAI at the same quality, they would have.
Yeah, they would have obviously preferred to do that.
Yeah. Like it would.
Yeah, it would have.
OpenAI would just be kind of, or like I don't know, like.
I'm not sure how much of a difference it would have made. Google also has like relatively different constraints that are advantages in some ways and not others. They're a public company who have to answer to investors in a way that is much more useful when you get to the point we're now at, where like you need public company, tons of like IPO amounts, or the amount of like giant cash that they have is like now pretty important and the sort of thing OpenAI would like. And you know, being a little bit more cautious than OpenAI makes sense for them to maintain that. It was like complicated, but yeah, I agree that they would have preferred to have done it. I mostly think of this as, yeah, you have like these startups who are willing to bet bigger, but this doesn't necessarily mean that whichever ones succeed were like smarter versus just like the ones who had the right idea.
Sorry.
The right idea being scaling.
But isn't it? Sorry, if you're smarter, you're more likely to have the right idea.
Yeah. I'm just like, you can't tell the difference between just getting lucky and having the right idea. And like having the right ideas.
There's but there's famously examples that people use of getting like the right idea over and over again, right? Like
I think that there is a degree to which this happens. Yes.
Yeah.
I'm like not clear. Yeah. I think that in fact the people at OpenAI made a number. I mean there were even earlier discoverers that were at Google. I mean Google was.
Yeah. I mean it's not like I think it's not super clear exactly, but I don't know. My sense is that like most AI researchers are like some people are just like obviously way more.
Yes, I agree that most AI researchers are this. I think of this as because people love thinking about like this is the sort of like mythologizing of your profession that can happen, where people like to think of like certain people as being special within their profession and like sort of view the differences between people as much more important than they actually necessarily are because they're very, very close to the issue. And you get a sort of like internal celebrity culture you can develop.
I mean, I agree that could be a thing that's happening and that could be bad, but also just if you look at metrics, it seems like the best performing researchers just are orders of magnitude more performing.
What are metrics?
Like if you look at things like publication count, if you look at things like pay, if you look at things like if you try to do some sort of
this is like
I know publication count kind of sucks, but also it is something that people are optimizing.
I agree.
So like it's a metric that the people doing the research care about.
Well, it's kind of rough these days though, because like if we're talking about AGI company employees,
I do think that the best researchers are better than the like median researcher by some amount. I think of this as like by how much?
Like we say 4x, right? Or like within the companies.
I don't have a strong opinion on the specific number here. Okay. I mostly think I think most of my disagreement here is going to come from a decrease to like the decreasing marginal returns to this.
Like after
you're running up against the limits or asymptotic the limits.
Yeah.
And then there I would just say, I mean, this is the classic argument we've been making since AI 2027 is that if you look at the distribution of the
it looks relatively smooth is what you're saying.
It looks like some sort of like heavy tail distribution. It doesn't look like the sort of distribution you'd have if it was asymptoting towards something. Like if it was asymptoting towards something, there'd be like a sort of more of a clump towards something. It'd be sort of like clumping towards the end, if that makes sense.
Yeah, I mean
whereas instead it feels like even in the tails, like there's still huge variation. Yeah, if that makes sense.
Yeah. What are the sort of things which might actually update me here? I'm trying to think, if I knew everything, if we knew all of the salaries of everyone at these labs, to what extent can we come up with cruxes that is based on this knowledge? Or if we knew like all of the internal financials of these labs, to what extent can I be like, this distribution doesn't look as... My guess, for instance, is that the distribution would not be as heavy-tailed as maybe your view would be, though I'm not sure. Like my guess is that the bottom 50% of OpenAI makes more than the top 10 makes more than the top 5 researchers at OpenAI combined. Yeah, I think that's true. At like most of the that like equivalently, if you want to estimate how much, yeah.
Another thing is like how how the company is structured internally. Like again, like you could take like my impression is that like for the way like kind of the research like the research direction setting works within the companies is like, there's kind of like there's like the structure where there's like research leads and then like there's like people like managing whole like research, what do you call it, whatever, like modules within the organization, and then there's like overall like a few people at the top like really trying to set the high level like organizational priorities, but like overall like especially like like anyone who's like not a research lead on like the bottom team, especially like they kind of like do like minor like kind of like experiment selection, but like they're not really contributing to like the high level research directions, and like especially like the kind of high level research directions are like really disproportionately set by like a smaller people. And again, you could take this, you could say, well, they're not spending much resources on it because like like it's not as important, or like the returns are already like diminishing a lot, or like like, but anyways, but you could also say like, oh yeah, the quality of the researcher matters a lot. So like like the fact that like there's really like relying on just like a few people to be setting these directions is some evidence that they're just like much better than the other people, basically. You could also just say it's like organizational dynamics or whatever, but I do think kind of like, yeah, my sense is something like, yeah, there's this kind of structure, and like especially like people near the top are really like the ones doing the kind of like overall like deciding what bets to make and stuff like that.
Should you expect there to be substantial turnover in terms of who is the top people at these labs as the number of people who are paying attention to this increases dramatically? And so you have a larger pool of like potential people who might have varying levels of research taste to select from? Like it would be pretty weird if, in 2022, all of the people who have the best research taste were already all interested in AI. According to me, that would be pretty surprising. There's a lot more people who are currently interested in AI now, and potentially you should expect to see a decent amount of turnover. You should expect it if you don't think it's in particular experience is very relevant here.
Yeah, I mean,
you could potentially think experience is very relevant.
I think experience is definitely somewhat relevant, but I think I mostly agree that like the people we should expect to see highly successful newcomers who only got involved in AI like a year or two ago and are making substantial contributions with it.
So not just highly successful newcomers, you should expect to see most like of the highly successful people be newcomers. The number of people at these labs is increasing more than 2x every 2 years.
I mean,
every 2 years.
Experience still matters. So
you have a leading, you still, if it's increasing 2x for 2 years at a consistent amount of time, the number of people with, as long as there's decreasing, as long as there's eventual plateau, you should still expect this to eventually be the case, right? No, you might expect, you should still expect the first people.
Yeah, I agree. Eventually, if it's fully meritocratic, I think obviously like to different levels within organizations, but to some and all of them, there's probably like various political dynamics and stuff. But yeah, I basically agree that like, I think we should expect to see some turnover. There's also like effects that I'm not really sure about that I've like.
I think I expect to see less turn. I wonder if we can like operationalize this into the amount of turnover we expect to see. Although
I think the problem is it's
different.
We're so far from being able to put numbers on it that we don't like when we see the actual number. Sorry, what I mean is both of our models are so far from being able to predict a specific number. I mean that like when we see a number, we don't know whether that's close.
I feel like your model should predict a lot of turnover. I could be wrong on this, and it might depend on the years of experience, but like the amount of people is definitely increased by dramatically.
Yes, but also they're lower quality people.
Also, they are lower quality people.
Yeah. That's
sorry, because you think that the initial people who, this is the claim I am making, which is maybe something you disagree with, is I like don't particularly think there's any reason to expect very high quality people, like all like a like significant bias towards the highest quality people working on this.
I don't think it's like an overwhelming bias, but I do think there is a bias. I think that like
it has to be very substantial if you imagine like.
Yeah, I mean, another thing you could say is like, to what extent are there like new organizations being founded that are doing productive things where like I feel like probably often what happens is like someone like is doing really well, but then like they don't get promoted or whatever, like they have some other disagreements, and then they go to like they found their own thing and do really well in that. I'm not sure to what extent this would, or like that seems like a thing that would more reliably happen than like a bunch of turnover within.
Yeah, I agree. Something I expect to see in general, I'm trying to think if there's a way.
I kind of want to move on to somewhat different things, but
sure. I'm good with that.
So I feel like we spent a lot of time talking about research taste. There's some other things on our list of possible things to talk about.
Happy to move on.
Which are somewhat related though, so we might end up finding our way back to research taste. Here's one: the value of n.
I don't know what n is.
Yeah, we've had a terrible naming decision to call it n, and we should rename it to something else. But basically, it's this parameter that's like, if you have an AI research project, and then it loses a bunch of its compute, like it has a 10x reduction in its compute, how much slower does it go?
So importantly, it's fully automated. Like,
Well, we can consider both cases, but
well,
let's consider the fully automated case for simplicity. But
Yeah.
it also consider today's.
yeah, we could also
Like we have some polling data where we asked people like, you ML researcher
Yeah.
doing your research, like how much slower would you go if someone slashed your compute budget by 10x?
Yeah.
but in that case, it's specifically software progress. Well, in the other case, it's overall progress.
Right. Yeah. And yeah, so I'm curious for your guesses as to what this parameter would be. In fact, I kind of think this is a tie into the research taste thing.
I would expect it to go substantially slower.
Yeah. So a 10x reduction
I don't
in
know.
compute, would it be like a 10x reduction in speed? Or
Let's say a 10x reduction in speed.
wow.
Like
okay.
today,
Even today, or do you mean in the future when it's fully automated?
Do I mean even today or in the future when it's fully automated?
Like it's more clear in the future case because it's like it's all just happening on the GPUs anyway. And so if you cut that, but whereas
My
today,
guess would be it would be something like a 10x reduction in speed. My reasoning for this is that it really does. There's like complications here. If it was like specifically the end goal here was a discovery of equal value or of like the same exact quality, then I'd be like, well, right now it sort of looks like OpenAI has to try at least 10 ideas in order to find one that works. So if you have a tenth of the compute, maybe you still try 10 ideas. You just tried a tenth as fast.
wait, but sorry,
Now you could try cheaper ideas.
sorry, but also you're assuming they literally have no ranking within the ideas, or they were just like try them random.
I mean, they do seem to try. I mean, like, I am meaning that the expected amount of compute they have to spend in order to get to the point where they have one good, that ends up going towards a file training run. This is like 10 ideas is also like not quite the right way of putting this.
Sorry, but like you've talked to like people like I don't know, like this is another thing we interviewed.
So I don't actually quite think it's 10 ideas.
There's another there's another thing we like interviewed frontier researchers about. We basically asked most of them this question, and like, yeah, I think it was a common theme that was like, like it would be a big hit, but like also like, like we would just like pick our most important experiments to run, and we would like run those, like we're we have some experiments now that are kind of just throwing compute at because we have to use it basically, like
I do think that like the degree of the hit I would expect the people who are doing the research to say you get is going to be way less than the actual. I just like there's a very obvious reason to be biased for them to think that no, actually it's their talent. That's like
I mean, we gotta,
I think that 10, also like the 10 might have been an exaggeration in terms of how many equally good ideas.
We got a wide variation of responses. Some people said it's not quite a lot.
Some people said more than 10.
No, I don't think no one said more than 10.
I think didn't we get some people saying that? Not in our surveys. I mean, in our comments on our doc.
But
that's a different situation. That was automation, right?
My oversimplified extremist view on this is that the amount of like algorithmic progress you get is just directly proportional to the amount of R&D flops you have done so far.
Right, makes sense. So
you go to tenth the speed. Yeah, I do think in this case you probably have a more complicated thing where you like try and aim for a smaller model, and so you like.
Sorry. Also, this is all for software progress, right?
Yeah,
so,
I was also assuming that you like
Okay, yeah. So but you could adjust your training strategy.
Yeah. Okay. Well, we settled that. I mean, we disagree for what it's worth. I think currently we're like at something like n equals 3, but like we are uncertain, obviously.
For present it's around 3. I think it's a little lower, like 2.8 or something like that.
One other thing that I would expect that would update me towards your view, and probably you think is I'll just let you say what you think of it, is if a company started spending a lot less on inference in order to spend way more personnel and R&D.
Yeah.
Yeah. I mean,
I think right now they're spending, oh man, I have these numbers written down, I'm not going to say them, but they're spending definitely like more than 50% of their spending is on inference plus R&D, and inference making up a very large chunk of that.
Yeah.
That is so far, I think, has probably been growing over time.
to be clear, are you talking about the gap between like serving customers to make money and like...
Yeah, inference I mean by serving customers.
Right.
Not,
So-
either like free users or, yeah.
That's right. And in your model, like the way to make AI progress routes through making money, which you then reinvest. Whereas
You don't quite reinvest the money. You get investors
Sure,
see
yeah,
your
yeah.
money and give you more. But yeah,
whereas in our model, that's a big part of it. But also we hypothesize that in the future, there will be like a faster loop of progress where you just make your AIs better.
oh yeah, this is another thing that I would expect is if you
And
if
so-
you see
Yeah.
Insofar as the companies start believing that faster loop is
Yeah, yeah.
paying off, then it'll become in their interest to have less on serving customers and more on doing that.
I mean, there's just even without
So-
that though, if they like decide that it's, by increasing their spending on both experiments and personnel by 20%, they can increase their the efficiency of their inference by a very by 50% or whatever. Then they should divert some of their inference spending just from a pure efficiency claim.
Yeah.
And so this sort of thing where it's the effectiveness of this research seems to scale pretty nicely and to a higher degree than I might necessarily expect.
Yeah.
Yeah, I think I would not be surprised. Yeah, I think I at minimum expect them during the intelligence explosion, or as we get closer, maybe let's say soon after they get AC or something, I expect them to probably condition on there being a taste only or software only intelligence explosion. Then I would expect them to at least increase the proportion of their spending.
Oh, conditional on that, I agree.
Yeah, cool. Well, we're saying movie indicators.
So we're
right?
agreeing with you.
One thing I'm concerned about is whether they would reduce the absolute amount. One thing that seems plausible is that they don't want to hurt customer experience or something, so they would keep it similar amounts, but then they would just get more on their
but the customer experience just as good as it currently is. With decreased
yeah, exactly. But yeah, I think that's what I thought at one point. But I was probably if they really want to, especially if they're doing this explosion, they have models that are now 10x, 100x less costly and stuff, and they can just replace those. So yeah, I think basically I do think that is a good indicator.
Yeah.
One other thing, by the way,
It's an indicator of what the companies expect, which by the efficient market hypothesis is what's going to happen.
I don't buy I'm not claiming the efficient market hypothesis is completely correct. I expect it to be, correct.
Yeah.
I expect it to be not radically wrong.
yeah.
That's my basic take.
I mean, I think Anthropic probably
Yeah.
pretty their beliefs aren't exactly the same as us, but I think it's something their beliefs are somewhat similar up until TED AI, and so if they're trying to do an intelligence explosion to get to TED AI, which is better than humans at all cognitive tests, then we would expect to see some behavior from them that would probably not look vastly different from what we would think is optimal.
Yeah.
When talking about the research taste, evidence that we get about research taste, one thing that's complicating it is that at least kind of in the framework of our model, there's the thing that matters is the research for takeoff is the slope, right? How fast research taste is getting over time. So if we got evidence of research taste, current AI research taste being good, I think I would have to think about I think that would plausibly actually be evidence for slow takeoff basically, because it's it'll move it probably will move through the human range, or has been moving through the human range at a slower clip than we might have worried. So yeah, basically I just wanted to mention that I think it's not obvious whether basically only an absolute level of research taste is more evidence about timelines than takeoff. For takeoff, we'd want to look at the trend.
Yeah. I think in general, in things that are just well described by I'm not sure which way I would actually expect this to point. Models seem to have done the sort of things which are described by X% of the population can do this well, then X divided by 2 can do this well, and so on and so forth. It seems like models have been getting better at it a consistent clip so far. And I'm wondering if there's a crux we can get to here, but I'm not actually sure there is. In particular, you can model this for math, where you can say this is as good as, the median high school student when you can do the median high school student math problems. And then later it's as good as the best high school. Okay, you can think about things like this. I'm not sure if there's actually good.
Sorry, we collected a bunch of data.
That's what we do.
That's great. Okay,
so far as you think there's a consistent trend there, then that's used for our model, because that's what we're trying to draw on.
I think that my basic take here is that I expect it to be less effective and not necessarily.
Industrial explosion.
Yeah, we haven't talked about that. Yeah. Let's talk about this. I think you guys are missing this. When I put in my parameters into your model, which you very nicely have allowed me to do, it just shows a flat line.
Yeah, I mean, we expect.
If I put in some coding stuff, it doesn't quite, but it shows a flat line.
Yeah, we say somewhere we're we don't model the feedback effects.
Yeah.
And you're but that's the whole thing.
Yeah. Or at least I don't see, when I sort of buy some coding speed up, so I don't quite see a flat line.
Yeah.
But when I turn the book, and so I'm but I have way faster than a flat line. I have it going. I have things getting really weird.
You want to make
you guys don't.
to our model? Then do that. I appreciate it.
I mean, this is the sort of thing that when I was talking earlier about our model, the embellishment that we have is I'm at some point, you get an economic explosion. I think the evidence for this is very compelling. Once you have automated all labor, literally all labor, it seems very compelling that you get an economic explosion, especially if scaling is continuing. even more so. So at some point, this like ECI to revenue linkage needs to cause revenue to start going up way faster than it has been historically. And there's some like questions about how exactly to model that and when that happens. But yeah, I like generally think that, I expect this to happen once we get to a certain level of capabilities. And this will lead to a world that looks like, our 2060 worlds, I think, look approximately as like alien to us.
Yeah.
As like we don't really have that big of a difference here.
Yeah.
In terms of like how wild they look. And even our like 2050 worlds look pretty similar, probably.
Even our 2040 worlds might look.
Yeah.
Maybe not. Maybe 20.
I think you're still a little bit ahead.
Yeah.
But once we're by 2050, it's like they're both equally bizarre.
Yeah.
Yeah. And this is like, I think people often make the mistake of thinking that like epoch slow timelines mean we think business is going to continue as usual, or like the future will be normal. And this is a bizarre future, a future with 30% economic growth. People often think of 30% economic growth as like a normalish thing, or like, the stock market's doing really well this year.
Yeah.
And it's like, no, it's a bizarre, it is, I think of it as like pretty similar to the Machines of Loving Grace Dario thing, which is bizarre. And I don't even expect that to continue for too long because I expect it to get way more bizarre than that.
Yeah. So I'm glad we have common ground there. So maybe we can push you on why it's only 30%. Or let's talk about that a little bit. So
Why, what's only 30%?
economic growth.
Oh, sorry, I think it's going to go beyond that.
Oh, okay.
To be clear,
Yeah.
absolutely think it's going to go beyond that, much farther.
Yeah.
I think that you get, by when I say like economic takeoff, what I am referring to is you have a like hyperbolic growth where the line hits, what would in theoretical models be infinite growth in finite time, and in reality will be growth until hitting some fundamental limitations.
Out of curiosity, what do you think those would be?
What do I think those fundamental limitations are going to be?
We have some discussion of this in AI 2027.
Oh man, I don't know. I would probably, like I said earlier, I don't have too much predictions of what happens after things go very bananas. I would not be surprised if I like agreed with your fundamental limitations. In particular, I think in that sort of scenario, you get enough intelligence that like, even if I'm skeptical of research taste now, you probably, I become less skeptical when you have a quintillion super duper intelligent AIs looking at it. Like eventually,
Yeah.
And I think I expect, you get a pretty weird world. I'm like not sure, but yeah. I think you get a pretty weird world regardless.
Yeah. So to put some numbers on it, like the way that we and others have thought about it is we look at doubling times of various other things in the universe, such as rabbits or grass or algae, and then we sort of anchor on those, and we're like, well, it's conceptually possible for like, mobile macro structure to reproduce itself in 1 month, like a rabbit or whatever.
Yeah.
So therefore, it should be possible for the giga super intelligences to design,
1 month seems like too long. Feels like you can do faster.
I think so too. Yeah.
I like what's their face's work on this. Forethoughts work on this.
Agreed. All right, so it seems like we basically agree on that then. Like, at some point, the economy will be like doubling every or something like that.
Yeah.
Like, Dyson swarms, crazy stuff.
I think I have a slightly higher upper end than some upper ends I've seen some people give. Mm-hmm. In particular, I think it's possible for it to keep growing exponentially, even like potentially indefinitely, which I think is not an opinion other people have.
Oh, that's interesting. So maybe we don't disagree about this. Maybe one thing we do disagree about, though, is that in the timeline that you gave at the beginning, you said 35 for all the cognitive labor and then 40 for all the physical labor.
Yep.
I would think it doesn't take 5 years after that point. And so especially if you're starting in 2035, when there's been more time for like robotics to have developed and the infrastructure to be built up. Like if you're starting today, it's kind of rough. But like on our projections, at least, in 2035, there should be like loads and loads of robots everywhere, even without AI assisting.
Oh, maybe we have different opinions about my expectation that I expect on the number of AIs. We're still doing initial research on this. I will have much better opinions relatively soon. My current take is it's not economically efficient to build a lot of robots. And when it is, I expect it to be on the high end of integration difficulties, or much more so than like AI diffusion is, where AI sort of integrate. Yeah. And for like the most economically competitive ones to be ones that are, require more specialization and things like this, where I expect robots to like definitely not be incredibly widespread by 2035. Do I want to make the claim? I expect there to be a lot more robots, but not like everyday life. There's a humanoid robot. There's like,
So I wish we had Romeo here because He's been mostly doing our like robotics predictions.
Yeah, I wish
for
I had
us,
JS here. He's
But
doing our robotics research right now.
but like at least our current take, that we're incorporating into a new scenario is that robots have been on an exponential trend over the last couple of years, and so we're extrapolating that into the future. And like we don't really see on a technical level any strong walls that we don't expect the robotics to break through, like sim to wheel transfer, stuff like that. I don't know, like based on our looking into it, it seems like like 5 years from now, something like Optimus might be a thing. Not like, it's able to do
Are you
absolutely everything.
specifically imagining humanoid robots? Because I'm even more skeptical.
I think the humanoids are like the like hard case compared to various other factors.
Yep.
But even the humanoid robots, like, I don't know. I mean, it seems to us like, yeah, maybe it is going to, even without AGI or whatever. Like, it seems like they are on some sort of exponential ramp up, and maybe we should.
I'm convinced that the financial, the finances work out for those.
Let's talk about it. I'm curious to hear.
I don't think that we should talk about it too much because I am much less well informed on this. My just general impression right now is that they are expensive enough and, not good enough such that it's much cheaper to employ a human.
Yeah.
I generally, one thing I do think will have a significant effect and that I do think boosts my timelines. I know Jaime has even longer delay times between robots, between human equivalent AI, between AGI and robots and things going bananas, is I think you can get a decent amount of uplift in terms of production capacity just based off AI assisted human labor.
This is the everyone has goggles.
Yeah.
Is telling you what to do.
I like presenting it in the context of a phone.
Yeah.
Because it sounds less sci-fi, but yeah, the goggles version is probably actually just doable now. They make them. It's gone way better over the past year. It's really cool. Past 2 years. But
yeah, you said.
Yeah.
Yeah.
That's an aside. And I think this sort of gives you a potential boost in high tech production that speeds up a lot of this. All the pipeline here. I also generally think that some other timelines, especially in terms of prototyping, won't be very hard, especially compared to some other things. My main thing here is that I think that just hardware I would expect to take over a lot more slowly than software. And the timeline between coming up with the ideas and implementing them and integrating them to take longer than I think you guys do.
I mean, yeah. So how much is the disagreement coming from the Daniel? If you thought there was no room above TED AI,
I think that I actually think that I feel like actually maybe I should have shorter timelines. My guess is AI 2027 was at the time of publication best guess as to how fast the industrial explosion would go. So specifically, it was 2027. If hypothetically by the end of 2027 you had all these top expert dominating AIs, and then they're getting even smarter than that thereafter. What does 2028 look like? And we talk about what it looks like, and it looks like this crazy industrial explosion where by the end of 2028 there's robots everywhere, right? And that sort of 1 year to get from automating the cognitive labor to automating the physical labor was a guess. We're not super confident in it, but it's a 5x difference between.
You don't just need to automate it. You also need to produce all the robots to get
That's
this
right.
thing.
But ours also involves the intelligence explosion continuing, right?
That's right. So we can break a couple of different versions of this. There's the version where it happens it starts in 2027 and they have superintelligence. There's the version where it starts in 2027 but they only have TED AI. And there's a version where it starts in 2035 and they have superintelligence, and there's a version where it starts in 2035 and they only have TED AI. And we can sort of say what order they're going to be in, right? The slowest one is the one that starts in 2027 with only TED AI, and then the fastest one would be the one that starts in 2035 with superintelligence. And the reason why the reason why those factors matter, of course, is that even if you're bearish on robotics, you must agree that there'll be more robots around in 2035 than in 2027 , right?
I agree with that. Yeah.
So there's more of an industrial base to start with.
I'm not sure how much I expect that to be. There's not. I expect the industrial base to still mostly be humans.
Okay, so
I don't think I really expect it to be. I think you have to have a lot of robots around.
Okay, so then maybe the 27 versus 35 difference doesn't matter that much. So let's talk about the TED versus superintelligence difference.
I also think that one thing is that it seems, my current guess is this probably doesn't, but there's some worlds where actually you see after AGI you see progress slow down in the short term because you are also seeing the limits of normal economic growth leading normal reinvestment just because you're hitting the limits of how much you can invest in AI. My current guess is that probably won't happen. You'll see something more smoothly increasing, but it's potential that you don't even, this goes back up once you actually have this really explosive economic growth due to having, a hardware revolution, but it's like not clear that this happens. Yeah, this is an aside. Let's go back to the thing and something I'm not at all confident in. Let's go back to robots.
Yeah. So, and this is something I'm not super confident in, but in AI Torture 7, we talk about how like you could take the existing car factories and then convert them to make robots instead. And, then you can argue about how long that conversion process takes. And then you can argue about like how many robots they'd be able to produce per year. But there's that type of reasoning that we were doing. And one of the like parts of our reasoning was thinking that like first we tried to guess like how fast humans could do it. And then if they like tried really hard, like if it was a sort of like World War II style, like we are now set our whole economy around producing these new types of robots. And then we were like, it probably goes even faster if superintelligence is in charge. But if you just have TED AI, then maybe it's like more similar.
It's not clear to me that like those factories can produce economically efficient. It's like a much harder thing to get like those factories, like the economically efficient robots. So robots that are actually like cheap enough that they're worth making large numbers of, and that you can afford to make very large numbers of, that are like cheaper than human labor. Seems to me like they might require sufficiently more sophisticated, like significantly more sophisticated factories than like currently existing car factories.
Do you think that like say the existing humanoid robots like the Tesla one, do you think that
I think they don't have, there's like substantial capabilities differences between them and humans.
it's not a matter of software, it's a matter of
Yeah, I generally am skeptical of software related bottlenecks to robot capabilities. I think there's a lot. I think you can do a lot better on the software if you wanted to, but people are not doing this because it's not worthwhile.
I currently disagree with this, and I would love to hear more. Can you say more about what the hardware bottlenecks are?
What the hardware bottlenecks are? I think it's
like it sounds like you're saying that even if we had literal superintelligence to steer the Tesla bot,
yeah.
it still wouldn't be economically viable to like produce them and send them to factories because like
how much are the current Tesla bots? I'm trying to remember the exact number.
I think they're about 100K.
Okay.
And then they say they're going to have them down to 30K in like a year or two. But we'll see.
There's also questions about repairability.
Yeah.
Which is potentially quite substantial, especially requires specialized skills and can't be done by another one. My general understanding here is like a combination of like speed, flexibility, and like ability to carry things, and like strength in like various parts of your body is something that like robots are not able to equal humans on all of those at the same time. I know this is like relatively significant, that you can't get robots that are like, can as flexibly hold heavy things and can like deal with all the sorts of scenarios humans can. And they're like relatively more limited. And also $100,000 is, I mean, it's competitive. Potentially
some professions.
Definitely for some professions, yeah. I would not be surprised to see them. That being said, the cost of those professions I also expect to go down just because of AI assisted. For blue collar work that were directioned by a like intelligence, I expect like AI assisted work to like drive the wages in those professions down already by a bunch.
Yeah.
So it like becomes harder for them to be cost effective in those professions too. I would be pretty worried about like repairability and like consistency here as well.
Consistency?
Just like the ability to like, in particular, the ability to like do things without breaking, basically, is what I am thinking.
But isn't that a software thing instead of a hardware thing?
That's not, sorry, do things without not breaking the thing that they're doing, breaking themselves, like themselves.
Breaking themselves, I see.
Yeah. I like the amount of compute going towards robot intelligence just isn't very large right now. And it seems to me like if this were a bottleneck, the people would be trying a lot harder to solve it. And there like seems to be some amount of trying harder to solve it, but it doesn't really, not really obvious to me that it's quite as much as I'd expect.
Yeah. I mean, I think the economics check out. I just, there's the whole like learning curve Wright's law thing where he says if it's 100,000 now, like I totally believe they can get it down to 30,000 if they scale up production a lot. That's just a normal learning curve thing.
Yeah, if it is sufficient, that is $100,000 now, and they can get it down to 30,000 if they scale up production a lot. I think my main claim is the thing that they have now is not actually even at 30,000. It's competitive with a lot of like AI assisted human labor for most things, or with specialized robots, but that's like more complicated.
I mean, another factor is that
insofar as those specialized robots are better, this is a bigger impact.
Like with a human, you need to pay them like maybe $25,000 a year. What would you think would be the wage?
It depends what you're doing. If you're specifically thinking about manufacturing, you can push that number way down.
To what?
I don't know, whatever minimum wage in or whatever twice minimum wage in a very poor country is.
Let's find out.
It's going to be way less than that, though, I think. And AI assisted labor circumvents a lot of that.
Okay. Like, about $3,000.
Yeah, there's some that go down to 1,000.
Okay. So
According to
that is pretty rough for the robots.
Yeah.
To like get that price down to like, I mean, if they got it from 30,000 down to like 10,000 or something, then they'd pay for themselves in a few years. But
they need to. You also need to note that the degree to which they pay for themselves, as economic growth goes up, they need to be able to pay for themselves in a smaller amount of time to make the investment comparatively worth it.
although note also that they can work 24/7, whereas a human has to.
Yeah, so that doubles. It's not. I think it's like that is an improvement, but it's like
Yeah.
I think that it's like compared to like AI assisted human labor, according to me, it's a tough case. You have to improve robots a decent amount. I'm also at least. I am not confident of this. I think we're doing like active research on robots, and it's the sort of thing we're looking into. I generally expect things in hardware to be harder for like complexity reasons and like supply chains, and things get a lot more complicated when you're not just dealing with software in terms of like automating them and speeding things up. But
Well, overall, I still am pretty bullish on the progress. I feel like the robots are going to get qualitatively better, and then of course also cheaper, even before we automate.
I expect them to get better and cheaper. Yeah, sure.
Yeah, and then I think
Just not by enough.
I think when you automate all the cognitive labor, the rate at which they get better and cheaper is going to go up a lot.
I also expect that. I just don't think it's going to be enough. This is why that is in fact a substantial part of why I expect 5 years rather than 10 years. This is like a difference between me and Jaime, is that I expect like automating all the cognitive labor to have a bigger impact on this than he does.
Interesting. Like you think it'd be 10 years without automating the cognitive labor, and then
Do I think it would be 10 years without automating all the cognitive labor? Yeah, quite possibly. Yeah.
Sorry, but okay, if part of your
Or more.
if part of your view is that like the AI assisted human
If he still thinks it has some effect.
like the AI assisted human labor will be like so cheap and efficient, doesn't that also like contribute to the stuff going faster?
Yeah,
So,
I think
like-
it does. This is why
Like it's
I
even
have 5
like
years.
is that a good or like a bad like
So I expect there to be, between these time periods, you're seeing very, very fast economic growth. And, it's just going to increase from there. I just still expect there to be a multi-year gap between the.
like where are you getting the like multi-year number from? Like is there like some Botek you have, or is it like
There is not really a Botek I have on this. It's more of like, I think there is some discussion from Jaime. Actually, I'm a little bit deferring some thoughts from Jaime about doubling times of various things.
okay, so there are some doubling times.
I think so. And this is the sort of thing which I expect to have a lot more thoughts of in like 6 months. We are like working on this,
excited
and
to
like
hear more.
hopefully are going to have something like this. Yeah.
Yeah, let me just say one more thing, which I think we never said. So Yafah said that her probability of a software-only explosion is 5%, and I feel like it might seem like Daniel and I are like very confident in it, but that's not true. Like our model has like this thing called a taste-only singularity, which is the main thing we look at because it's easier to sort of like measure in our model, where it's only a singularity from research taste and not coding abilities. But that said, we think like this is like kind of a lot of the probability mass of crazy intelligence explosions comes from these. And yeah, anyways, in our model, I have like about 40% on a taste only singularity, something around there. And I think Danielle is about like 55%. Though again, this is like like things can still go crazy without a taste only singularity very fast because, for example, coding matters, or like, there's hardware R&D automation or stuff like that. But yeah, just to give a sense of where we're at though, in terms of like, yeah, we're not near like 100% or anything.
I want to know what your choose percentages are. So like my 5% is approximately if you choose is roughly correct. What is the thing that I've used for that? Like I'm curious about what your two percent that like Epoch or I am roughly correct. What answer would put on that?
maybe 5%.
I think sorry.
Think about it so much.
Sorry. Like there's a difference between
say
being
it,
like
I'm-
correct, like ex ante. Like I should, like if I thought a while, I should.
No.
user-
No.
Oh,
That,
like the word looks roughly what you currently predict.
Yeah.
Oh yeah. That seems possible.
Okay.
Like
Cool.
maybe like 10 to 20%.
Yeah.
Ish. Yeah.
Yeah. One thing I think people should think about a bit more is not just like what they think is going to happen or what they think is reasonably likely to happen, but the range of opinions that they think are reasonable. And I think this tells me a lot about like what sort of things people are thinking about. And I think you guys definitely are in my like range for that.
Thank you very much. You as well. Like I said, I put lots of weight on the like just extrapolate revenue, bro. Like
Yeah.
like
I'm doing a little bit more than
Yeah.
that because we
Yeah.
have data on more
more
things.
money. Yeah.
Yeah. Okay, cool. I think that's
Yeah.
I think that's it.